All right, welcome to The Explainer. Today we are cracking the code on, well, on motion itself. We're talking about the three fundamental rules that run the entire show, how everything moves, from a planet orbiting the sun to you just walking down the street. So let's dive right in. So let me ask you something right off the bat. What do you have in common with, say, a soccer ball just sitting on the grass? I know, it sounds a little weird, right? But believe it or not, the answer is the key to unlocking the very first and maybe the most fundamental law of motion. And that answer? It's all about something called the law of inertia. Honestly, the best way to think about this is it's the universe's default setting. It's the rule for what happens when things are just left alone, with nothing messing with them. Okay, so here's the official definition. It says that an object will stay at rest, or it'll keep moving at a steady speed in a straight line, pretty much forever, unless some kind of external force gets involved. Now, you have to understand, this was a huge deal. For centuries, people just assumed things naturally slowed down and stopped. They just ran out of steam. Newton said, nope, that's not how it works at all. So, let's break that down. In plain English, it just means stuff likes to keep doing what it's already doing. You could almost say objects are kind of lazy. Think about it. Have you ever been on a bus or a train and it suddenly slams on the brakes? You go flying forward, right? That's because your body wants to keep moving at the same speed the bus was going. That feeling, that lurch, that right there is inertia in action. Okay, but let's be real. Things are rarely just left alone, right? There are forces pushing and pulling on them all the time. So what happens then? What happens when a force does get involved? Well, that brings us right to the second law. This is the rule for change. So the second law is pretty straightforward. It says that when you push or pull on something, when you apply a force, it accelerates. It changes its velocity. And the more force you use, the faster it accelerates. Simple enough. But there's a catch. And that catch is mass. The heavier something is, the more force you need to get it to accelerate at the same rate. I mean, think about it. You can send an empty shopping cart flying with a small push, but try doing that to a car. Yeah, not so much. And this whole idea, this whole relationship, gets boiled down into one of the most famous equations in all of science. F equals m times a. Force equals mass times acceleration. I mean, look how simple that is. But don't let that fool you. This isn't just some dusty old formula. It is literally the recipe for change in the universe. Everything from figuring out a baseball's curve to calculating the orbit of a planet, it all starts right here. All right, so we've covered what things do when they're left alone. And we have the formula for what happens when you force them to change. But there is one more piece to this puzzle, and it's a big one. The third law is kind of like the hidden rule that governs every single interaction that happens, anywhere. And you've definitely heard this one before. It's famous for a reason. It's just so elegant. For every single action, there's an equal and opposite reaction. What that really means is that forces never, ever happen alone. They always come in pairs. No exceptions. Let's make this super concrete. Imagine you're pushing against a wall. Just picture it. You might think you're the only one doing the pushing, but you're not. The wall is pushing back on your hand with the exact same amount of force. That feeling of solid resistance, that's not just the wall being strong. That is the wall pushing back. That's Newton's third law. And this action-reaction thing, it's literally how we get to space. A rocket engine fires, pushing all that hot gas downwards with incredible force. That's the action. And the reaction? The gas pushes the rocket upwards with the exact same but opposite force. It's not the ground pushing the rocket up. The rocket is literally pushing itself up by throwing gas down. So here's where it all comes together. Because these laws don't just exist in their own little bubbles. No, they work together constantly, like a perfectly coordinated dance. And there's no better example of this than that rocket launch. So let's use it to tie all three laws together. Okay, let's walk through it step by step. First up, law number 1, inertia. The rocket is just sitting there on the launch pad, totally still, and it would stay that way forever if nothing happened. Then law number 2 kicks in. The engines fire up, creating a massive amount of force. which is what you need to accelerate the rocket's gigantic mass. F equals ma, remember? But where does that force come from? That's law number 3. The engine pushes gas down, that's the action, and the gas pushes the rocket up, that's the reaction. And that upward force is what finally overcomes the rocket's inertia and sends it screaming into the sky. See? It's a perfect logical chain. So what's the big takeaway here? The main thing to remember is that these aren't just, some random rules in a physics textbook. This is the invisible operating system for the entire physical world. It is the code that's running in the background dictating how absolutely everything moves. And that brings us to the end. But it leaves me with one last question for you. Now that you know the rules, now that you can kind of see the code running behind the scenes, where are you going to see these laws in action next? Thanks for joining me on The Explainer.